this is Sidra and this is our lecture for Chemistry Class 8. The topic that we are going to study today is isotopes. We all know that atoms have three subatomic particles that are protons, electrons and neutrons. Protons are positively charged, electrons are negatively charged and neutrons do not have any charge, means they are neutral. The number of protons and electrons is always equal in an atom, which makes it neutrally charged. So if the number of neutron is changed in the atoms of the same element, it will not affect the charge of the atom and the atom will still have a neutral charge. Now as the neutrons are neutrally charged, so their number does not affect the charge of an atom. And secondly, an element is identified by its atomic number, which is the number of protons. So what are the isotopes? Isotopes are atoms of an element whose nuclei have the same atomic number but different mass number because of the different number of neutrons. Now same atomic number means same number of protons, which is specific for the atoms of a specific element. All the atoms of a specific element have same number of protons, which makes the atomic number. Okay, but the number of neutrons is different in different atoms of the same element. Isotopes are chemically alike and different in physical properties. As the neutrons do not take part in chemical reactions, so they do not affect the chemical properties of the isotopes. They only affect the physical properties of the elements, of the atoms of the elements. Now the discovery of the subatomic, if we remind about the Dalton's atomic theory, then there is a point in which he says that the atoms of all of a specific elements have same atomic number and same mass. Now and same number of subatomic particles. But when the number of neutrons will be changed, the mass number of the atom will be changed. So that point proved to be incorrect. His theory was not discarded by the scientists, it was only revised. Means the number of neutrons affects the mass number. Mass number is actually the number of protons and number of neutrons. So the mass number may be different for the atoms of the same element, but the atomic number is always the same for the atoms of a specific element. Now let's study about the isotopes of hydrogen. Hydrogen has atomic number 1 but mass number is 2 or 3 also for the different isotopes. There are 3 isotopes of hydrogen. One is protium, then there is deuterium and then there is tritium. In protium there is only 1 proton, so atomic number is 1 and there is no neutron, so mass number will also be 1. Then comes the deuterium. In deuterium there is 1 proton, which means that the atomic number is 1 and there is 1 neutron, so the mass number will be 2. Then comes the tritium. In tritium there are two neutrons, so mass number will be 2 plus 1 3, but atomic number is same, that is 1, because of the presence of 1 proton in the nucleus. The most abundant form of the hydrogen isotope is the protium, which is present in the ordinary water, and it is H2O. But there is also a heavy water whose formula is D2O and it contains deuterium in it. What you have to do, you have to search about the heavy water and then you will find out the differences between the heavy water and the ordinary water. Okay, the melting point, boiling point and density differences are given in your textbook, but you have to study more about it. Tritium is not found in the naturally occurring hydrogen because its nucleus is unstable. Then comes the isotopes of carbon. Again, carbon has 3 isotopes. These are C12, C13 and C14. And again it is due to this 12, 13 and 14 is actually the mass number. And the atomic number of carbon is 6. It means there are 6 protons in all the 3 isotopes, but the number of neutrons is changed. In C12 there are 6 protons and 6 neutrons, which makes the mass number as 12. Then in C13 there are 6 protons and 7 neutrons, which makes the mass number 13. And then in C14 there are 6 protons and 8 neutrons, which makes the mass number as 14. So the most abundant form of carbon isotope is the C12 isotopes. That's why it is included in the periodic table. Different forms of carbon are black or grayish black solids except diamonds. They are odorless and tasteless. They have high melting point and high boiling points, and they are insoluble in water. These are the properties of the isotopes. They are given in your textbook. You have to give the you can write the definitions in that topic. Like the topic of isotopes of carbon is given, first you can give the heading of introduction, then you will give the heading of C12, then you will write the subatomic particles of C12, then there you will write about the properties of isotopes of carbon, then you will write that different forms of carbon to the end of the line, that is the insoluble in water. Okay, clear? Then there is activity 2.1 is given, in which the isotopes of carbon are drawn, and you have to find out the most abundant form isotope of carbon is also given, which is C12, that is present in the 98.8% in the nature. Okay, so it is most abundant form isotope of carbon. That's why C12 is taken in the periodic table. Then comes the isotopes of chlorine. Again, chlorine has two isotopes which are natural, and these are Cl35 and Cl37. An atom of chlorine 35 has 17 protons and 18 neutrons, which makes the which makes the mass number as 35. An atom of of Cl37 has 17 protons and 20 neutrons. Okay, Cl35 occurs in nature about 75% and chlorine 37 about 25%. So Cl35, that's why we take it in the periodic table. In periodic table we write the mass number of chlorine as 35. Chlorine is a grayish yellow gas with sharp, pungent, irritating smell. It is fairly soluble in water. We all are quite familiar with the smell of chlorine because it is also added in the water to kill the germs. Okay. Then there is again the activity 2.2 is given on page number 35, and it is about the abundance of the isotopes of the chlorine. There are two isotopes, that is one is present in 75.77% and the other is 25.23. It is given in the last paragraph, and you have to write about which isotope of chlorine is present in more abundant form. Then comes the isotopes of uranium. Again, uranium has three isotopes with mass number 234, 235 and 238. Now they are named as U234, U235 and U238. Atomic number is 92 for all the three isotopes. Okay, uranium 235 isotopes in nuclear reactors and atomic bombs. Okay, it is radioactive element, so it is used in nuclear fissions and in atomic bombs. Natural abundance of uranium isotopes is as follows, that is uranium 234 is only 0.006%, then uranium 235 is 0.72%, and then comes the uranium 238 is 99.27%. So U238 is the most abundant isotope of uranium, and it is included in the periodic table. Okay, then you have to do the activity 2.3 on the textbook. You have to just write about the subatomic particles, the number of the subatomic particles in all the three isotopes. Then the chemical properties of an element depend upon the protons and electrons, and the neutrons do not take part in chemical reactions, so only the physical properties of the isotopes are different. Otherwise, chemically, isotopes of a specific element are always same. Then another very important topic is the uses of these isotopes, and you have to learn these uses very carefully, because a question containing 5 marks mostly comes in the paper. 3 to 5 marks is very common for the uses of isotopes to be included in the exams. Now, radioactive iodine 131 is used as a tracer in diagnosing thyroid problems. Iodine, the isotope of iodine is 131, which is used in diagnosing thyroid problems. Then sodium 24 is used to trace the flow of blood and detect possible constrictions and obstructions in the circulatory system. Iodine 123 is used to image brain. Cobalt 60 is used to irradiate cancer cells in the hope of killing or shrinking the tumors, like in the chemotherapy. Then radioactive isotopes are used to date rocks. Now the process of dating is also explained in the pink box on the in your textbook on page number 36. Now carbon 14 is the isotopes which is used to find out the dating process about the life of the organism. Like when in the sea, they used to absorb the carbon 14, all the living organisms used to absorb the carbon 14 isotope, and after that this process stops, and with the by measuring the quantity of that carbon C14 in the in the dead bodies, the life of that organism can be found out. This process is called the dating. It is given, a paragraph is given on page 36, and you have to learn this also as a use of the isotopes. Then carbon 14 is used to trace the path of carbon in the photosynthesis. It is also used to find out the path of the carbon as a nutrient or as a mineral in the process, the use in the process of photosynthesis, and it is also helpful. So these are the uses of the isotopes. You have to prepare this topic fully. I think it is very clear to you. Then comes the tasks. Now you have to read and learn page number 33 to 36. This is a very important topic. It can come in the sections, or you can find a full question to be attempted in the paper, and it is very easy. You can divide it in the sections and you have to prepare it. Then complete the weekly assignments and submit on AIS. Now you have to do these assignments on the loose sheets, but first you have to prepare it from the textbook, then you will search it on the internet. Okay, now what you have to, after going through the textbook, after learning and studying the topic thoroughly, then you have to do this assignment. Okay, then the first question that you have to do is, what is an isotope? Who discovered it? Compare the isotopes of carbon. I have explained the isotopes of carbon to you. You can gather more information and you have to write it down on the loose sheets. Then comes the draw isotopes of chlorine. Again, you have to just draw the isotopes of chlorine, and then you have to write their differences. You can write their properties. Chemical properties will be same, but the physical properties will be different, and then you have to write out their differences. Then write a short note on the isotopes of uranium. What is the difference between heavy water and ordinary water? Draw structures to support your answer. Then last question is the exercise questions, that are question number 10, 11 and 12, and they are related to this topic. Okay, solve all these and then submit your assignments on AIS, and I'll check them and return the assignments to you. I hope this topic is very clear to you. Thank you so much. Allah Hafiz.